This is lecture 36 on urban transportation planning. We will continue our discussion on transport related land use models and complete the discussion in this class itself. You may recall in the previous class we finally discussed about the basic principles related to Lowry's land use model and then the important steps involved in the application of the Lowry's model in land use prediction. What are the 4 important steps in the application of Lowry's model in land use prediction? I will just show you the same flow chart that we have seen earlier to illustrate the 4 steps. Step 1, exogenous allocation of basic employment. We did not make use of the model to allocate basic employment. These employment locations are fixed based on other data collected from various sources. Then endogenous allocation of population / households. This is done using the model, right? And then endogenous allocation of population serving employment. This is also done through the modeling process. And finally, check for constraints on population and population serving employment zone wise. That is what is to be done as a last step in the application of Lowry's land use model, right? And let us just recollect the set of equations related to Lowry's model. The equation system involves the following equations: P is equal to E into A and ES is equal to P into B and E is equal to EB plus ES. Of course, P is nothing but a row vector of the population or households within each of the zones considered, say n zones, and E is a row vector of total employment, right, and ES is again a row vector of service employment, and EB is a row vector of basic employment in different zones of the urban area. A is an n by n accessibility matrix giving information about the probability of an employee living in J but working in I, right, and B is also an n by n matrix giving probabilities of service type R being used by people living in J, whereas service type R is located in I, right. So, these are basically accessibility related matrices A and B, right, and please recollect how we calculate the value of A. A is obtained as A dash ij into Aj, as you may recall, and A dash ij, as I said, is n by n square matrix of the probabilities of an employee working in I and living in J, and Aj is again n by n but diagonal matrix of the inverse of the labor population rates as employees per household or employees per 1000 population and so on, expressed either as population per employee or households per employee. And similarly, the B matrix is given as B dash ij into Bi, where B dash ij is an n by n square matrix of the probabilities that the population in J will be serviced by the population serving employment in I. Bi is n by n diagonal matrix of the population serving employment to population ratios, right, certain number of service employment per given population value per 1000 and so on. Clear? Please remember these equations while we take up a numerical example to understand the application of Lowry's model, right. Let us consider a simple numerical example involving just 4 traffic zones in an urban area. The following are the details given to us. Total employment vector E is given as 126, 177, 64 and 216. It is simply a row vector of employment details in the 4 traffic zones. A similar vector giving information about basic employment 100, 150, 40 and 200. Obviously, these numbers pertaining to EB will be slightly less than E, because E is the total and EB is part of E, and these numbers are fixed by the planner. These numbers cannot be obtained through the modeling process because it is related to basic employment, right. Journey to home function A dash ij is given like this. This is a 4 by 4 square matrix, right, and how do you understand the cell value 0.3 in the first row? Anybody? Maybe I have to provide you this information. This is nothing but probability of an employee working in I while living in J, right. Then this 0.3 means probability of an employee working in zone 1 but living in zone 2, that is it, okay. And 0.35 obviously is working in zone 1 and also living in zone 1. That is how we need to understand these numbers. The other related question is this: how do we get these numbers in practice? Nobody will give these numbers to us when we plan or when we try to predict the population distribution for the horizon year for an urban area. We have to get these numbers. Is it possible to get these numbers for base year condition? This is base year data only, isn't it? We are using base year data to predict the future population distribution. Yes, we conduct different types of surveys, including home interview survey, wherein we get detailed information about all the characteristics for each of the trips made, isn't it. So, trip origin, destination, trip purpose, etc. is known to us. Definitely we can find out of a total of say X employees in a particular traffic zone, how many are employed in a given zone, isn't it, living here and working in another zone, because total employment is known to us, trip origin, destination details are known to us, and trip purpose is also known to us. So, these numbers can be easily found for base year condition. So, these proportions are given as probabilities, isn't it. 0.35 is nothing but 35% of the total of the trips made for basic employment is within that zone itself, that is the meaning, okay. And similar information related to employment in service related industries, population serving employment. Probability that population in J will be serviced by population serving employment in I. For example, 0.45 means what? Probability of population serving employment in zone 2 being served to the population living in the same zone, isn't it? That is how you need to understand these numbers. Labor participation rate, households slash employees, AJ is a diagonal matrix. Why it is a diagonal matrix? After all, this information pertains to only 4 traffic zones. So, you can have only 4 entries and rest of the cell values will be 0 only, clear. But still we want to have the same number of rows and columns because it is a diagonal matrix. You cannot just have a diagonal matrix with 4 entries without entries in the other cells, because it should be a 4 by 4 matrix. And similar information related to service employment ratio expressed as households per service employment, BI values. Again, these are just only 4 entries pertaining to the 4 traffic zones, again a diagonal matrix. The values are 0.2 in all the 4 cases. It is a very simple direct case, but in practice it need not necessarily be like this, okay, could be different. Now, with the information provided, A and B matrices may be determined first using equations 4 and 5. Equations 4 and 5 just now we have seen, equation for A and equation for B. I will again show you the same equation so that we just follow closely. A is equal to A dash ij into Aj. The values are given to us now. We know the value of A dash ij in a matrix form. Aj is also given in the form of a diagonal matrix, and B dash ij value is given in the form of a square matrix, and Bi value is given in the form of a diagonal matrix. So, it is going to be multiplication of matrices. This means you should be able to recollect your matrix algebra knowledge. For the benefit of those who may not be able to recollect quickly the required information for this purpose, let me just give you a brief on the relevant aspects of matrix algebra so that you appreciate the subsequent analytical steps. Okay. This is an m by n matrix. There are m rows and n columns, isn't it? Symbolically, matrices can be represented as shown on the right hand side. So, where A11 to Amn are the cell elements, represents the numbers that are the elements of the matrix obviously, and for identifying the matrix whose element in row I and column j is Aij, for every I is equal to 1 to m and j is equal to 1 to n. That is how we designate the cell elements as Aij, right. I refers to the row elements and j refers to the column elements. Okay. Let A and B be 2 matrices having the same number of rows and same number of columns, okay, square matrices. Then A and B are said to be equal only when or only if all of the corresponding elements are equal. Element corresponding to 1 1 in A should be same as 1 1 in B. So, all the cell elements should be same, all the corresponding cell elements should be same, then you can say both the matrices are equal, otherwise they are not equal. The operation of multiplying the matrix by a number, denote this number say by k, is performed by multiplying each element of the matrix by k. That is how we need to understand multiplication of matrix by a constant. Let us say we need to multiply matrix A with k. So, this implies k goes in and gets multiplied by each of the cell elements. If you take this numerical example of a small 2 by 3 matrix with cell values of 2, 1 by 3, 2, 5, 0, minus 3 being multiplied by 3, you can see simply multiply the cell elements by 3 to get the product of the 2, right. Then about addition of matrices. To add A and B, what do? We simply add the corresponding elements. Okay. The value of 1 1 in A is added to the corresponding value 1 1 in B and do the addition. A plus B is obtained as a matrix with cell values as Aij plus Bij. To illustrate, let us consider this simple matrices 2 by 2 matrices A and B with cell values of 5 3 1 6 2 0 3 1. So, we simply add the corresponding elements 5 plus 2 7, 3 plus 0 3, 1 plus 3 4 and 6 plus 1 7, right. And how do we subtract one matrix from the other? We do subtraction indirectly through addition only. We just assign negative value for all the cell elements of the matrix which is to be subtracted from the other one, that is it, and simply do again addition of the two matrices. A minus B is treated as A plus minus of B, that is it, right. Let us consider the same set of matrices 5 3 1 6 2 0 3 1, one is subtracted from the other. So, simply we subtract 2 from 5, 5 minus 2 3, 3 minus 0 3, 1 minus 3 minus 2, 6 minus 1 5, clear. So far things were much easier and with matrix algebra, but multiplication is little complex. Matrix multiplication is more complicated. To find the element in row I, column j of the matrix resulting from multiplying A times B, right, or multiplying matrix A with B, it is necessary to multiply each element in row I, right, of A by the corresponding element in column j of B, right, and then to add these products. So, the columns of one matrix is related to the rows of another matrix, unless there is some connectivity between these columns and rows, we will not be able to really do multiplication, right. Therefore, the matrix multiplication is defined if and only if the number of columns of A equals the number of rows of B, right. Number of columns of A equals the number of rows of B, because this condition is required if we are to perform the specified element by element multiplication, because it is column to row multiplication. So, we need to have this condition satisfied for matrix multiplication, right. Let us take a small example and see how this multiplication can be done to understand the concept better. Thus, of course, if A is an m by n matrix and B is an n by r matrix, then their product is symbolically represented like this. Okay. I and j values are involved. Let us consider this numerical example. We need to multiply a 3 by 2 matrix, is not it, 3 rows and 2 columns, 3 by 2 matrix by 2 by 2 matrix, 3 by 2 by 2 by 2, is that acceptable? So, 3 by 2 matrix and 2 by 2 matrix. So, we can do multiplication. What do? We just consider the row, first row of the matrix, and then the corresponding column is the first column. We multiply 1 and 3 plus 2 second element of the first row and second element of the first column, 2 into 2. So, this summation gives you one cell value for the product, clear. Then we consider the same first row, but the second column, 1 into 1 here plus 2 into 5, the corresponding element. So, this is another cell value, clear. And similarly, next we take the second row here and then multiply each of the columns of the other matrix, 4 into 3 plus 0 into 2, 4 into 3 plus 0 into 2, right. And similarly, this is one cell value, and then 4 into 1 plus 0 into 5 is another cell value. And finally, considering the third row, 2 into 3 plus 3 into 2, one cell value, and then 2 into 1 plus 3 into 5, another value. So, the result is, so we get a 3 by 2 matrix, again 3 by 2 multiplied by 2 by 2 gives you 3 by 2 again, 3 by 2 matrix. The cell values are 7, 11, 12, 4, 12, 17, right. We will do a similar exercise while getting the values of the accessibility matrices, namely A and B, in the application of Lorry's model. Is that clear? Now, let us try to get the value of A dash ij into Aj. A dash ij value is this given to us, Aj value is this, and product of these two. So, we are multiplying a 4 by 4 matrix by another 4 by 4 matrix. So, the condition is satisfied, is not it? Satisfied or not? Satisfied. So, we can multiply and we can get the result as shown here. Same rule is applied, I am directly giving you the result, right. On the same lines, get the value of B as B dash ij into Bi. B dash ij value is given to us and Bi value is also given to us. Multiply the two matrices to get the value of B, and the value of B is this, right. So, we have the accessibility values both as A as well as B matrices. Now, we are ready to use the basic equations of Lorry's model to get the required values. The household vector can be calculated from this equation, P is equal to E into A. The value of P is given to us, is not it? Do we know the value of P? No, P value only is being calculated, right. E and A are known to us. Total employment vector is given and A we have calculated. So, we have to calculate the value of P. P in this case is taken as households, not population. P refers to number of households in each of the traffic zones, right. Again we are multiplying. What is the size of this? It is a row vector. If you want to express this in matrix form, how do you designate this as a matrix? 1 by 4 matrix, 1 by 4 multiplied by 4 by 4. What will be the result? You will be getting only 1 by 4 matrix, okay, and this is the result. So, you get values of 95, 128, 101 and 142. These are the predicted number of households in each of the 4 traffic zones as per Lorry's land use model, right. Then use the value of P to get the other values. The service employment vector may be calculated from this equation, ES being equal to P into B, and we know the values of P now as well as B is known, and get ES value as P multiplied by B, okay. Again we will get 1 by 4 matrix. 26, 27, 24 and 16. So, these are the number of service employments that will be located in each of these traffic zones, right. Yes, please.
Sir, we can directly find the ES vector by in the formula E is equal to EB plus ES.
Yeah.
So, ES is E minus EB.
Yeah.
So, we can directly find.
We can directly find out, that is also possible. This is also possible because I am doing it, and then we can get it because E is known to us, EB is also known. So, we can get ES value, that is also possible, okay. Now, equation 3, you may recall what the equation 3 was, may be used to check if the household employment allocations are internally constant, okay. This is what we do, we do this for just checking. We estimate ES value differently and then sum up both and check whether it is matching with the total employment value which we have already got. So, the given value is this 126, 177, 64 and 216, that is known to us, and now let us add these values EB and ES, and if you add this, the simple addition of the cells, we obviously get the same numbers 126, 177, 64 and 216, is not it. So, your predicted value is matching with the actual observed value of E. So, we can say that the calculation of A, B as well as ES is logical, clear. Of course, this indicates that the co-distribution of employment and households is in equilibrium, clear. Now, there are certain issues. If there is no match between your calculated and actual observed values while you are checking, we should know how to tackle such situations. In that context, let us look at these allocation functions. The A dash I j elements of A matrix may be estimated empirically in the following way. I have already shown this equation in the previous class itself, is not it? It is a gravity type of equation to get the value of A dash I j. Please remember, in this example just now we have seen A dash I j values are directly given to us, right, but this is the way the A dash I j values are actually estimated. H j is what? Is a measure of the attractivity of zone j for household location. How to get some value for H j? Any suggestion? It is a measure of attractivity of zone j for household location. I will show you the explanation for the other term also, so that you will be able to think comprehensively and respond. F w I j is the travel time factor between zones I and j. Travel time factor we normally express as a function of the actual travel time, is not it? We do not take the travel time itself to represent the resistance to mobility, we just express it as a function and get some number. F here also represents the friction for mobility between zonal pairs, which reflects the manner in which the spatial separation of zones, right, influences the residential location choices of employees with respect to their workplace. That is the meaning here. W stands for work, right. So, with the explanation given here, would you be able to suggest some methodology to get the value of H j? F I j we can get, because the travel time can be measured easily between zonal pairs, and there are standard functional forms available to express the spatial separation between zones in terms of friction, travel resistance or friction factor. We can get some value for F I j, but how do we get the value of H j? It is just related to the attractivity of zone j for household location. How do you measure the attractivity of a zone j? Household location means, of course, it should be first suitable for construction of houses, the zone itself. So, first it is related to topographic and even geographic condition of that particular location in an urban area. Okay, normally you can assume that topographically and geographically most parts of urban area will be suitable for house construction, of course adhering to the zonal guidelines, right. If a particular area is designated as a residential zone, the planners would have looked into the suitability of that area for housing purpose and designated that portion as a residential area. So, we can basically assume that topographically and geographically the designated areas for housing will be already fixed, okay. But still we need to have some value of H j based on other factors. What are the other factors? Because as planners we should know or fix some value for H j, otherwise you cannot get the value of A dash I j, which is again a very important input to get your A matrix value of A, is not it. What are the other relevant factors to get some measure of H j, which is nothing but attractivity of a zone for household location? Yes.
The reach of a workplace can also be a measure of attractiveness for the zone in a residential location.
Yes, her point is the accessibility to workplace could be one of the factors governing the attractivity of a zone as a residential area. Is it acceptable? Yes or no? Yes, it is acceptable. So, we fix our residence in an urban area based on several factors. What are the factors that we have in mind while fixing our residential location? Let us say you are just transferred to a new city and you want to fix a suitable location for housing first, workplace and your residence, then that is the only activity in which you will be involved. You will just go to work and come home and sleep. There
should be nearby schools. We look for
nearby schools,
then hospital facilities, shopping facilities,
and so on. So, that is how we need to understand the value of or fixing the value of Hj, or please simply think of the different purposes for which we make trips. What are the purposes for which we make trips? Starting from work, education, shopping, social recreational, right, personal business, isn't it, like visiting post office, bank and so on, right. Yes. So, we keep all these things in mind and then fix a particular location as suited for our housing, right. Now, the related question is, how do we get the value of Hj for all the zones in the urban area? It should be relatively acceptable value. When you say that zone 100 is better for housing than zone 90, there should be some indicator to compare. We should arrive at some numbers, isn't it? How do we get these numbers? So, think of the ease of access to all these activities, trips made for all the purposes, right. Then rank a particular zone based on ease of accessibility for all trip purposes, and within that you can give weightages for certain trip purposes. For example, education and work, you can give a higher weightage, right, and access to health service, maybe you may not do it regularly, occasionally, right, you can give a lesser weightage. You cannot give equal weightage for all activities. So, it is a detailed process of assessing the suitability or attractiveness of each of the traffic zone for the purpose of housing, okay. And it is very difficult to really arrive at a very accurate value of Hj for all the zones in an urban area. You should do a thorough analysis of accessibility to all activities and assign suitable weightages, aggregate all these things together to get the value of Hj. Clear? So, that is how we need to get the value of A dash Ij. Of course, equation 6 will be recognized as a gravity type accessibility expression, as I said earlier, and similar exercise has to be done to get the value of B dash Ij also, and this is related to suitability of a zone to fix what? Population serving employment location, isn't it? And of course, for this purpose we disaggregate service employment into odd types, as I indicated to you earlier, because you cannot just consider all types of services as similar in nature. We have to disaggregate them based on the frequency of access required by the residents. Some services are accessed on regular basis, daily basis. Some services are accessed maybe once in a week or alternate days and things like that. Based on the necessity for accessing services, we can categorize the services into different types, right, as well as based on the other intensity of activity related to different services also we can categorize. For example, if you take educational services, as I mentioned to you earlier, kindergarten, elementary school, middle school, high school, people might access these services every day, but still you cannot or there is no need to locate a high school at frequent intervals, whereas there is the need to locate kindergarten at frequent intervals. So it is also related to the nature of the service being provided. So this is the equation about which you are familiar. So SIR is a measure of the attractivity of zone I for satisfying the service type or needs of the households. And FIJSR is a travel time factor between zones I and J, which reflects the manner in which the spatial separations of zones influences the type or service location choices, right. So in this context, can you suggest a methodology to get value of SI R? Let us say R refers to, right, education service in the form of middle school. How will you fix the measure of attractivity of a particular traffic zone to fix a middle school, to locate a middle school, is not it? The whole discussion is based on the assumption that the service related employment opportunities and population should be spread logically in such a way that the services are accessed easily by the residents. That is the concept based on which we distribute these two endogenously using the model, is not it? How do we find the attractiveness of a zone to locate a middle school? We are locating this facility using the model, is not it? Yes, yes please.
We can do that by having the number of, estimating the number of kids who are getting a middle class education in an area. With that survey we can get to know the attractivity of the students being occupied in the school, and also with the amount of bus services available, so that how many people can use a bus service to reach the middle school.
Yes, to some extent the point is right, but while fixing the service related facility, you must keep in mind the type of facility and its horizon, the catchment area, okay. Accessibility is obviously one factor, and then the coverage by a particular service, that is also important. By fixing a middle school in zone 100, if you are able to cover more traffic zones than fixing it in 99, then 100 becomes a better zone for fixing the service than 99. So of course obviously you consider accessibility and other related aspects. Yes please, you have some
one
point.
question, like as in news we all see that there is a survey for the best cities in the world and all, so which is the more attractive city to for residential. So do these studies come into picture and that is how it is determined with that which is the best city? Like today they say Sydney and Melbourne is the best city to stay.
Yeah.
So do these equations and all, what is the real applications, are they being they are applied there, sir?
I do not think they apply these models very in a religious manner. I would say that those statistics are based on stated preference approach. They interview different sections of the people, urban dwellers in different parts of the society belonging to different socio-economic groups, and then assign ranking, weightages and things like that, arrive at some number. because this kind of detailed exercise for macro level comparison is difficult, because it is data intensive. Unless you get detailed database for all these calculations, it may not be working well. Mostly the livable cities, the statistics that is given out are based on stated preference by the residents of the respective cities, as well as opinion from general urban transport system planning or urban planners in general, experts all over the world. That is how they get these ranking based on the attractiveness of cities for living. Right, that is how the point to be understood here is getting correct value of SI is crucial, which is a detailed process. As we saw in the earlier case, getting the value of Hj, SA value only will govern the value of B dash Ij r. If there is some error here, then there will be error reflected in the value of B dash Ij r, which in turn will reflect in the value of B, and finally we will be in trouble while checking the correctness of the prediction of the distribution of population and service employment. And please remember in this context the zonal constraints. While applying and predicting, applying Lowry's model and predicting the horizon year values, you should see that P, household or population distribution for various zones, should be less than or equal to the zonal capacity in terms of number of households or the population for each of the zones. And another important factor is ESR should be greater than or equal to ESR minimum. You should provide the minimum required service, okay, for any traffic zone. These are all zone wise details. Service type R, okay. Service type R may be available in some other zone, but it should be accessible to the other zone which is associated with that particular service. That is how we understand ESR and ESR minimum. Let us say unfortunately when you apply Lowry's model, of course the explanations are known, if equations 8 and 9 are violated, not satisfied, what do we do? The new accessibility matrices must be developed. Fresh values of A and B are to be calculated, first calculating the correct values of A dash Ij and B dash Ij, and the equation set 1 to 3 again, the first 3 equations solved again using the new matrices, right. How it is being done? One approach to this problem of developing a distribution of activities that satisfies the constraints, equations 8 and 9, is to use an approach similar to the attraction trip and balancing procedure of the gravity model. When they are matching, it is fine. When they are not matching, follow the same iterative procedure, right. I am just giving you the essence of it. We calculate a new value, A star Ij is a new value using a modified formula. The only modification that you find here is, instead of Hj we are writing H star j, and similarly in denominator it is H star j. That means the problem lies there in assessing the attractivity of traffic zones for a residential location in this case. That is the detailed exercise where we are likely to commit mistakes. Fij is normally estimated reasonably correctly. So we must go back and check for the correctness of the estimation of the value of Hj, the ranking procedure, weighting methodology, all those things you must check, recheck and come back with the new value of Aij and use this Aij value to get the value of A, clear. Similarly, to get the new value of B dash ij or for type OR service B star, new value has to be calculated. Here again you can see that Si is the culprit and we have to get an acceptable or corrected value of Si, okay, rework the attractivity of zones for locating service type employment or service type activities, and then rework or recalculate the value of B dash ij or, then substitute these values in the basic equation for B and get new values of B, right. That is what is given here, in which A star ij and B star ij are the new estimates of A dash ij and B dash ij to be used in the next iteration of the model. So, we need to understand that application of Lowry's model of land use prediction is going to be an iterative process in practice. Even though in the given numerical example it was very direct and satisfied the requirement, in practice it may not happen in most cases. You may have to do it iteratively until there is a match between the predicted and actual estimated values, right. So, this completes our discussion on land use related or transport related land use models, right. To summarize what we have done today, we just recollected the different steps involved in the Lowry's land use model. Then we took up a numerical example to understand the application of Lowry's model, and while taking up the numerical example, we found that the analysis involves matrix algebra knowledge. So, then we discussed the basic aspects which are relevant to this exercise in respect of matrix algebra involving addition of matrices, subtraction of matrices and multiplication of matrices. Then we just did the calculation related to the given example to check whether we are able to apply the Lowry's model systematically to get the predicted values of the population or households and service employment zone wise, right. Finally, we discussed about the possibility of the predicted values not reflecting the actual observed values. In that case, we have to rework on the attractiveness of traffic zones for residential location as well as attractiveness of zones for location of service related employment, right. So, with this we will complete our today's discussion. In the next class we will discuss about urban structure, which is a new topic, right.